There is also a different method to solve the same question that does not use hints at all, right? So let me explain how we can do this if we do not know the answer, if we don't know that the limit is zero and we don't have any hints, right? So this is how I would actually approach this question myself, you know, if I had something like this on the final exam. Now, first of all, we don't know what the limit is, right? So, and with limits of functions of two variables, there is always we can always suspect that there is no limit, right? So, and in order to check whether to prove that there is no limit, we usually use limits along different paths, right? So, we can look at the limit along a path, say y equals kx, right? So, where k is some real number, right? And if we do this, it means that we will have to replace y with kx in the given expression. So then we will get x cubed minus 5x squared times kx divided by x squared plus k squared x squared. And this is really, so we can cancel by x squared. This is x minus 5kx divided by 1 plus k squared, and the limit of this is 0, right? So because we can just let x be 0. Okay, so the limit along any straight line um, except for the line x equals 0 is 0. So we can try the line x equals 0. So what if we try the limit along the line x equals 0, right? So but then we would just need to replace x with 0 in our expression, and then replacing x with 0, we get essentially just this is 0, this is 0, this is 0. Well, it is basically just 0, right? So again, the limit is 0. And so we see that the limit along all straight lines is 0. It, strictly speaking, it doesn't yet mean that the limit is 0, but it's sort of a strong evidence that we kind of suspect that the limit is 0, and we might want to prove that the limit is 0, right? Um, so we kind of believe that the limit may be 0, right? So we wanted to show. So if we kind of try to do it and we fail to do it, then maybe we can't. So the next thing that we can try is, since there is x squared plus y squared here, and we know that whenever there is x squared plus y squared, a reasonable thing to try is to use polar coordinates. Because in polar coordinates, x is r cosine theta and y is r sine theta. So in polar coordinates, x squared plus y squared is r squared cosine squared theta plus r squared sine squared theta. Then we can factor out r squared, so it's going to be r squared times cosine squared theta plus sine squared theta. But cosine squared plus sine squared is always 1, so it's just r squared. Right? I'm sorry. No. Basically, my point is that in polar coordinates, x squared plus y squared is just r squared. And it's kind of just, whenever your expression has x squared plus y squared, if you use polar coordinates, it is going to, this substitution is going to simplify your expression, right? So that's the logic here. So this is why we really want to use polar coordinates. All right. Now, when we change these to polar coordinates, what we get is really the limit as r tends to 0 of what? Of r cubed cosine cubed theta minus 5 r square cosine square theta times r sine theta divided by r squared. Okay, so now let us look at our expression. So r squared we can cancel out, right? So this is really r times cosine cube theta minus cosine square theta times sine theta, well, times 5. There's going to be 5 here. All right, and we've got to take the limit of this expression as r approaches 0, right? And again, so here we've got to use squeeze theorem too, but here is kind of it's easier. I mean, so now we realize that we need to use squeeze theorem because we work with trigonometric functions, and you know, trigonometry is a strong hint that a squeeze theorem is going to help, because trigonometric functions, sine and cosine, they are naturally estimated by 1 and negative 1. Right? So this expression can be estimated from above and from below. This is less than or equal than r times what? Uh, Basically, the maximum possible value is when cosine is 1, because cosine is between 1 and negative 1, right? Then cosine square theta is cannot be negative, right? So it can be 0, it can be 1. But what if cosine is 1 and sine is negative 1? Then this is really 1 plus 5, right? So this becomes 1 minus, let me just try, 1 minus 5 times 1 times negative 1. And this is 6r. And so what we immediately see here is that our expression is less than 6r. And basically, because of the same reason, our expression is going to be bigger than or equal than r times, well, we've got to just reverse all the signs. So to make this expression as you know, to find a lower bound of out for our expression, so the minimum value is going to happen when a cosine is negative 1 and sine is positive 1, and then we will have minus 6, right? So basically our expression is bigger than or equal than minus 6r. All right, so what we see here is that our expression that we are estimating is less than or equal than 6r and bigger than or equal than minus 6r, and r approaches 0, so both upper bound and lower bound approach 0. So again by the squeeze theorem, um, the answer is 0. So but the um, so we in the end we've come to the same conclusion, of course. But the advantage of this method with polar coordinates is that here we don't have to have any hints, right? Um, so, and it is probably more natural to use the squeeze theorem because so here, because of polar coordinates that we introduce, since we see x squared plus y squared. So whenever you see x squared plus y squared, it's just a reasonable thing to do, to try polar coordinates. And once we introduce polar coordinates, basically we see that a trigonometric function appears there. And whenever you see a trigonometry in your expression is just like a natural, a very reasonable thing to do, to try using squeeze theorem. And again, so here, you know, in order to come up with estimates with upper and lower bounds on the results, on the result, you don't really need to use some clever inequalities, or to remember to work with absolute values, or to remember um, the triangle inequality. So it's kind of just more natural. So which is why, you know, if I get this question, I would probably use the trigonometric method instead.